Now students, today we will learn the chapter of 12th standard and which name is three-dimensional geometry. Now we can start the chapter which name is three-dimensional geometry. First, I tell you my name. My name is Dixit Lakshman Rao from Shri.C.L College, Mazalgaon. Now our chapter is three-dimensional geometry. It is very important chapter of 12th standard. Now you have heard the word dimension. So what is meant by dimension? First, we discuss the word dimension. Dimension means, just like in general we can say shape of any objects, but in three-dimensional geometry, dimensional means it has three important points. First, length, breadth, height. It is also called as width. So this is considered in dimensional. So in three-dimensional geometry we have to learn, but before this we see some important dimensional figures. You know, the first dimensional figure, just like as this is cuboid. Now this is the cuboid. Now here it figure has height h, it figure has width, and it has length. So this is the figure of three-dimensional cuboid. Next, or we can say cube. Cube is also a three-dimensional figure. Just we can say that we are living in three-dimensional. In our hall, this is our three-dimensional. So what is the purpose of this three-dimensional geometry in our mathematics, that we have to see here. So first, this is the dimensional, means we have to consider here 3 points: height, length and width. So that's like cuboid or cube are the shapes of that dimensions. So in this chapter, three-dimensional geometry, in this chapter we have to learn about mathematics which used in geometry. So let's start first the figure. Now in three-dimensional geometry we have to discuss the first three definitions first of all. The first definition is directed angle, direction cosine, first we clear this definition, directed angle and direction cosine. So for that we draw a figure just like Now in two-dimensional, we have seen x and y axis, but here three-dimensional geometry, there are three axes, x, y, z. Now this is the origin. We can draw the line passing through O. Here is P. Similarly, it passes through P dash. Now here we can also consider the line L. We can also consider the line L. Then what happens? This x-axis, y-axis, z-axis means this is three-dimensional, this is width, this is length, and this is our height. Now here, that OP line creates the angle. So first is that angle is alpha. Now next, that y axis that creates angle beta, and OP line that's create angle gamma to z axis, and that L line, this L line is parallel to that OP line. So here OP line creates the angle x-axis alpha, creates the angle beta y-axis, creates the angle gamma z-axis. So this line creates three angles, that is alpha, beta, gamma. That angles are called as directed angles. Now the line OP makes an angle. The line makes an angle with x, y, and z axis are alpha, beta, and gamma. Then these angles are called as a directed angle. These angles are called directed angles. Now similarly, OP makes angle alpha, beta, gamma with x, y, z axis, but here that L is line parallel to OP means that L line is also make the angles alpha, beta, gamma to x axis. Means that any line parallel to that OP line that also makes the angle alpha, beta, gamma to x axis. So this is called as directed angles. Okay. Now here is three-dimensional. First I will also explain that this is x axis, this is y axis, z axis. Now this is three-dimensional. That is our length, that is our width, that is our length. This we have discussed first startly. So here that OP lines make alpha angle, OP line makes beta angle with y axis, that OP lines make gamma angle with z axis. That three angles are called as directed angles, and L line is parallel to that OP, so we can say that L line also makes an angles alpha, beta, gamma to x axis. So that alpha, beta, gamma or angle made by the line is called as directed angle. And so that L line is also make the angles, because why? Because OP is parallel to L, so that alpha, beta, gamma are called as directed angles made by the line L. Why? Because that two lines are parallel. Okay, so this is the directed angle. So next is we see direction cosine. Now in generally we know all trigonometric functions. So what are the trigonometric functions? Sine, cos, tan, cot, sec, cosec. So here direction cosine. So what is meant by direction cosine? So here we also call cos as cosine. Cos, generally we say cos, but it is actually cosine. So we have to calculate the cosine of that angle is called as direction cosine. We have to calculate of that cosine angle of that alpha, beta, gamma is called as direction cosines. So what happens? So here therefore we can say that here cos alpha, comma, cos beta, comma, cos gamma. So that cos alpha, cos beta, cos gamma means cosine alpha, cosine beta, cosine gamma are called as direction cosine of the line. And it is denoted by L small m n. It is denoted by small l m n. That is, we can write here L is equal to cos alpha, m is equal to cos beta, and n is equal to cos gamma. Means that cosine of angle which creates by line are called as direction cosine of that lines. So in these 2 points it is clear that alpha, beta, gamma are called as directed angle, and that angles of cosines, that is cos alpha, cos beta, cos gamma, are called as direction cosine of that line, and it is denoted by small l m n. That is, L is equal to cos alpha, m is equal to cos beta, and n is equal to cos gamma. So we have clear that two definitions, directed angle and direction cosine. Now we will see some examples from that. But before this, we see what are the direction cosines of x, y and z axis. So here we clear some remarks. So that axis x, that is y, and that is z, means that x axis creates angle 0 degree. Now y axis create angle 90 degree, and that z axis create angle 90 degree. Remarks we have to see, x axis creates itself 0 angle. Now it is perpendicular, that is 90, and it is also perpendicular 90, means the directions cosines of x axis are, that is L is equal to cos alpha, m is equal to cos beta, n is equal to cos gamma. So therefore L is equal to cos 0 m is equal to cos 90 and n is equal to cos 90. So we have the value of cos 0 is 1, cos 90 0 and cos 90 0. So therefore the direction cosine of x-axis, direction cosines of x-axis are 1 0 0. This is our first remarks. Direction cosines of that x-axis are 1 0 0. Now second remarks, what will be? Now here that y-axis means its itself angle is 0. Now that z, its angle is 90 and that x, its angle is 90. Therefore cos alpha m is equal to cos beta, n is equal to cos gamma. So here here angle first it is 0, it is 90, it is 0 and it is 90, because y-axis, this is x, it is 0 and it is 90, so it is 90, so it is 0 and it is 90. So therefore L is equal to cos 90 0, m is equal to 0, m is equal to 1 and n is equal to 0. Means the direction cosine of y-axis are 0, 1, 0. So that are the direction cosines of that y-axis. And last number third, direction cosine of z-axis are, means z-axis, that are the angles creates first 90x, x-axis 90, that is y 90, and z-axis itself angle is 0 degree angle. So here, so 90, so here is also cos 90 and so here is 0 degree. So this is 0, this is 0 and this is cos 0 value is 1. Therefore direction cosine of z-axis are 0, 0, 1. So that are the remarks for 3 axes. Direction cosines of x-axis are 1, 0, 0. Direction cosines of y-axis are 0, 1, 0. Direction cosines of that z-axis are 0, 0, 1. So this is for only understanding. Now that two definitions, we have to see some important examples which may be asked in our examination. So first we will see how that examples.